Okay, hello everyone, thanks for coming. I'm Jimmy and I'm a part of the Facebook team. We're the developers of V-Ray. And today that's what we're going to talk about. I'm going to talk about V-Ray. But before that, I just want to show you one video clip. I don't know if you know, but this year we had our 10th anniversary, so V-Ray just turned 10. And our friends in LA just made a video for us. It's very funny and I just want to show you.
And ready? Ready?
Okay, focus, okay.
Hello. I'm Christopher Nichols, lighting supervisor. I've worked on such films as Tron Legacy and David Fincher's To Go with a Dripping Tattoo. And on V-Ray's 10th anniversary, I'd like to talk about, show you the many ways that V-Ray has changed my world. It started off in architecture, and it's a tough business. At this level of demand, you need true ray trace reflections. And you need true GI, not something faked with ambient occlusion. Architecture tells a story that can be personal, offbeat, grand. V-Ray is the perfect tool to tell these stories, because I am at heart a storyteller. In the f***ing car!
So when I transitioned to film, I knew that V-Ray was the only way to go. Because it's not just architecture clients, it's the audience and everybody.
Scott, he says tell him about the dome lights.
Tell about the dome lights.
He's right. Not everybody knows you can calculate image-based lighting with direct illumination of that. Everybody knows that. Not everybody.
Oh, you're not everybody for us.
Guys, just trying to get through this, please.
You're waiting for Harry to go through smart final embedding.
Right?
Screw it. Let's do this.
Everybody down around! Nobody be a hero. We're here for the bank's money only.
I don't agree to that, but all right. When V-Ray does HDRs with a dome light, that's important setting, which means you get clean renders much faster.
Yeah, but it's a biased engine. I mean, everybody knows we want physical accuracy. We want to use unbiased.
I don't have 12 hours for a f***ing render. Unbiased. You want to look real? Just make sure it has Fresnel. Everything has Fresnel. Right? Everything has Fresnel. Yeah, that's Lucency. Just a two-sided shader. Works great. Even in shadows. We're in. See that? And you got a ton of stuff. Just use proxies. I rendered like a billion polygons with like 0 RAM. Are we happy?
Actually, hold on a second. Kind of missed the crumb balls. Jinx! Now you'll be a coke.
Of doing sub-circuit scattering. Stay with me, man. Stay with me. You can make it. You can make it. Make it. This is exactly what I'm talking about. See how the blood and the skin
You guys should check the new hair shader. Good example. If I have a question about physical accuracy, just use the new camera. It was amazing. Doing looked at. Just a piece of light. Moving around too.
Sorry, girls. I'm a married man. B-Ray. 10 years.
Some interesting people using V-Ray, obviously. Maybe not the best actors. So, you heard what Chris said, and yeah, in the beginning, V-Ray was mainly targeted for architects, to the point that if you say, I'm using V-Ray, people are, oh, you're an architect. And we've been trying to really change that way of thinking for a while now. So today I'm going to be talking about V-Ray, and I'm going to show it in Maya, because basically the VFX people are using Maya. Now, we know that one of the hardest things and the most time-consuming parts of a process in our production is basically setting up materials, setting up all those complex shaders and lighting. And the problem was that every time you change something, you need to wait for all the pre-passes of the GI to complete, and then you have to wait for all the buckets. And basically this leaves you no other option than to harness your inner piece and just stay there and meditate maybe. So a couple of years ago we decided to fix that, and we introduced something called V-Ray RT. The V-Ray RT is our interactive rendering technology, which allows me to render my images on the fly and see the changes immediately. Now the new thing that I'm showing you here is that with the latest in-house build of V-Ray for Maya, which is going to be released anytime now, we can actually run V-Ray RT directly on CUDA. So in the past we could only run it on the CPUs, and this allowed us to basically have exactly the same result as the production rendering engine, which is our main goal. And we've been working really, really hard to be able to do the same thing on CUDA. And this is, let me tell you, it's been quite a struggle because basically architectures are different. But as you can see now, everything works on CUDA, and I'm just going to show several examples of the kind of performance that you can expect and what you can do with V-Ray RT. So as you can see, RT is a progressive path tracer, which means that it progressively increases the quality of my image. It starts at a lower quality, and then it's going to add more and more samples, constantly clearing the image out. And this can be very useful, especially to new users. So I'm not sure if how many of you are actually using V-Ray and how familiar you are with it. But to new people, it can get a little bit confusing, all the different settings for GI, for anti-aliasing, and it may take a lot of attempts until you get the perfect image. But with V-Ray RT, the only thing you care about is those two options over here. So we have trace depth, which means that you're going to tell V-Ray how many times you want a ray of light to be reflected or refracted at the maximum. And you have GI depth, which basically tells you how many GI bounces you're going to calculate. And from then on, V-Ray takes in just a few seconds you can have a perfect image. You don't have to understand any of the render settings, obviously. So that's pretty cool. And as I told you, however, the main idea was to be able to quickly set up shaders and materials. So I just want to show the interactivity here, and basically the moment you change something, Vero is going to react and show you the effect of what you've done. This works for lights, this works for materials, basically anything in the scene. This is actually a pretty complex example that I'm showing you here. You'll see that we have all these materials are all water reflections, and we have several area lights, and we also have an AHR in the environment, as you can see. So this is a complex thing to render, but because we're using the CUDA, the graphics cards, we're able to do that very, very quickly. And the cool thing again is that I will create exactly the same image with the standard rendering engine, with the V-Ray production render. So let me show a couple of things that were from a real production. I have this model here. It was given to us by Rob Netherhost. Actually, he was one of the guys in the video that you saw. And in this video, what we want to do is do a little bit of loop development. So I'm going to fire a party, and you'll see that in the scene I have this object here, this is actually a very dome light. And the very dome light is our way of doing image-based lighting. So as you know, image-based lighting is the process in which you put an HDR in the environment and then you use global illumination. The problem with that is that GI creates nasty results unless you have really high settings. But with the dome light, you can see we're able to clear out those very quickly because we have direct light. And this will allow me to use this kind of lighting in all my scenes very quickly. So if I need to set up correctly the position of my environment, I can very quickly just take the place environment node here and play with the rotation until I'm happy. And again, RT allows me to immediately see the result. Now once I'm happy with the lighting, I can play with the material. And this was one of the hardest things to do, to be able to actually render blend materials. So simple materials are not that hard to render. I mean, just mirrors, diffuse materials, things like that are pretty simple. But we have this material called V-Ray blend material, which basically allows me to stack several materials on top of each other. That's exactly what I've done. So I have this material, and on top of it, I have another one. And by using this blend amount value here, I can specify how much of each material I see. So completely black means that I'm seeing just the bottom material, and completely white means that I see the top material. So basically I can stack up as many materials as I want here, and I'm showing you an example of that a little bit later. But being able to render this on the graphics card was very difficult. And we're now capable of doing this. And to really get the idea of this material, you really need to use some textures. So let's bring in a texture here. And I'm going to use this texture. So wherever I have white, I'm going to see the top material. Wherever I have black in this texture, I'm going to see the bottom material. Which, if I connect it to the blend material, this rows here, and use it for blend amount. Here is going to have to move the texture into the memory of the graphics card, and then in a second we'll see the result. Okay, so you can see now at some areas the paint is still there, at some areas the paint has been scratched out, and this is a very intuitive way of working. You can see how you can integrate this into your pipeline a little bit later. Now something else about the scene, you'll see that this actually has an animation, and a very important feature here is that it's able to recognize this. So you can use VRT to preview your animations and make very quick previews of your animation. Now, as I told you, V-Ray is going to render forever. Basically, it constantly improves the quality. And if you want to use it for animation, you need to do some setting up. In here, we have a maximum render time, which means that I can tell V-Ray never render each frame for a maximum of 1 minute, right? Or I can give it a maximum paths per pixel, so I can tell. Because from frame to frame, maybe you have different things are visible in the shot, and 1 minute it's something that's simple will create better quality than in 1 minute it's something that's very complex, right? So you can basically specify how many samples per pixel you want, and something like, let's say, 32 samples per pixel is going to create a nice enough quality. And I can show you something that we did like that. Here is the animation that we used. 2 Tesla cards for 1 minute per frame to preview this, and you get the result. And we even have motion blur, so if you're dealing with that, you can also see the motion blur here. Now, V-Ray is going to take full advantage of all the hardware that you give it. So if you, for example, have more than one graphics card on your machine, it's going to take that. And if you want to, you can actually go here into settings, and we have some options for distributed rendering, which means that I can basically bring in additional power over the network and render it out. So this can be useful, for example, if you're in a hurry and the client is next to you and he's really precise about all the shaders and all the shadows, how they should look. You can sit next to you, he can sit next to you, and you can do working on that and get the desired result. Now here's something very interesting. It seems that nowadays all the new movies are in 3D, so this has put a little bit of pressure on rendering, because you have to render each frame twice. And setting up the perfect distance between the eyes, it takes some time. So let's very quickly go into RT and just enable stereo vision. And I'm going to hit render. So in stereoscopic renderings, you have to think about two things. First of all, it's the problem that you need to render the image twice, and then you need lots of depth of field. Basically, if you want to bring the attention of the viewer to a certain something in the scene, you need depth of field. Everything should be blurred out, and just the things that you're looking at should be in focus. So V-Ray allows you to kind of set up this very quickly. Here I have the images for the left and the right eye. And the obvious thing is that they're too far away, so I can adjust the eye distance. And I can see how things look immediately in stereoscopic, so if I have glasses, I'll be able to see that. And the other thing that I can do here is I can, for example, select my camera and go to the physical camera settings and control the F number. As you know, the physical camera completely matches the real world camera, so the settings for the F number is going to affect the amount of depth of field. So if I increase the F number, I'm going to get less depth of field, less pronounced depth of field effect. And if I decrease it quite a bit, we're going to see a very, very heavy depth of field. And again, all blurry solutions like depth of field, glossy materials, all these things, they are rendered much more quickly when using character because of the architecture of the engine. And I can also play with the focus distance, so if I just go and specify focus distance and then say something like 25 or 25, I can put the focus somewhere around here, as you can see now, and then I can move somewhere in the back. So this is going to make things much more easy for me when setting up stereoscopic images like that. Obviously my depth of field is very, very here right now, so let's increase it a little bit and we'll see a better result. Okay, so the last thing I want to show you is about RT. This solves one of the main issues with rendering on graphics cards, and that's the fact that most graphics cards, they don't have enough memory. And in this scene, we have instances of this plane, and we have almost 15 million polygons. And this is something we're very proud of, is the ability to actually use instance geometry in the memory of a graphics card. The developers tell me that this is extremely difficult to do, but we managed to enter this feature, so we can render millions and millions of polygons on the graphics cards, which is again a great advantage, because most graphics cards, they do not have 16 gigs of memory like your regular render node has, for example. I can see we get exactly the same performance, HDR illumination, and we also have all these glossy materials. So another important thing for any rendering engine is to be able to be easily fit into a production pipeline. And we've been working really hard with the guys from Foundry to make V-Ray compatible with their products. So you'll see later that, for example, V-Ray works almost seamlessly with Nuke, because we get all these render elements and it can work with Nuke. And I don't know how many of you are familiar with the product called Mari. Yeah, you have heard of it. So it's basically a tool that allows me to paint some textures, and as far as I know, it was developed in-house for this movie with the blue aliens. I don't know if you heard it, it's Avatar. Yeah. So it was developed especially for Avatar to be able to paint huge data sets inside of directly on the geometry. So you can see you can exactly the same geometry that I have here in my scene. It has been brought into Mari, and you can paint textures, you can paint masks for these textures. And this kind of works very well with V-Ray in two ways. First of all, if you don't want to unwrap your geometry, you can bring it into Mari, paint the textures directly on the geometry, and then save a ptex. Have you been using it? Yeah? So it's pretty cool because V-Ray actually has this ptex node that allows me to basically bring in the ptex and render it with V-Ray. And the new thing that I'm going to show you here is the ability to actually render something called UDIM textures. So if we quickly check the UVs of this object, you'll see that they're actually not in the 0-1 space. What we have done is different parts of the object have been unwrapped and just moved to the side and to the upwards. So basically when we give this to Mari, we bring this geometry into Mari, we can do some texture painting, and Mari is going to create these textures. And it's going to save separate files for the separate squares that you see, but those files will have a specific name structure. So they will have like coordinates. This piece fits at this particular UV space, for example, from 3 to 4 and something like that on the first row. And I can bring this into V-Ray then, and I'm going to show you this material here. As you can see that we have a very complex shader. We have 4 different materials. We have one that is the base metal, which is some rusty metal. We have another part which is metal, just a blue metal. We have yellow paint, and we have dirty oil marks. And they're just the materials that we created, but the interesting thing is that the textures that we're using in the blend material to make those are those UDIM textures. So let me show you this. For example, this is the texture that we're using to specify where the dirty parts are going to be. You'll see that if I hit view, nothing happens because I cannot hold it. The my node doesn't understand the file node. But I can open this here and go to the UDIM. You can see these are all the textures for the dirt. Because I have these UVs and given them to Mari, Mari has created the textures with a certain name here. You can see 1001, 1002. These are different squares. And what I have done is I will select this, for example, and I'm going to say where it says dirt point, I'm going to remove the name of the file, the number file, and I'm going to type in UDIM. So now what happens is V-Ray understands that this is a part of a UDIM texture, and it's going to load it correctly. And this allows me to basically create this result. So let's try and render this. And again, I'm going to use RT. You'll be able to see that this is one shader, one V-Ray blend material. This one that actually creates the whole effect. And this works so well with Mari. The reason it works so well with Mari is because they have the same layer structure as we do. So they have different materials and different masks on top of each other. So we directly transfer it into V-Ray and can render it. But I strongly suggest if you're not familiar with Mari to take it because it will really make your life easier dealing with textures. So otherwise I would have to have like 20 different file nodes for each of those small pieces of texture and connect each to the correct object, and it would be hell. But this way it's much easier. Okay, let's move into this. It's basically the same scene, but in this one, what I have done is I have split the whole image into render elements. And for every big production, it's very important that you split your renderings into render elements, because this gives you like unlimited amounts of control in compositing. It allows you to do really cool stuff if you know what you're doing. I'm going to show you some Nuke comps that one of the guys from the foundry made for us. So V-Ray is basically, in the very beginning, it started being developed for this company called Machiavision, for very strong users of Nuke. So all the render elements that we developed, they work with Nuke natively. So you just bring all the, for example, you can split the image into reflections, refractions, specular, so on. You just add them in Nuke, you get the final image, and then you can apply color corrections on just the reflections or on just the small part, for example, just the speculars. But there's a certain other type of render elements that allow us to do more interesting things. For example, we have the z-depth, which allow you to put depth of field in compositing. You have the velocity, which will allow you to, for example, put motion blur. And we have those render elements called multimatte. Now the multimatte can be very useful because it allows me to create selection masks. And I'm going to render one out. So the way selection masks work is that for any material or any object inside of your My scene, you can go to attributes and add extra V-Ray attributes. And those can be called material ID or object ID, which basically allows me to give a number to either a material or an object. And then I can specify inside of this multimatte render element that I want in the red channel, I want to see all the objects which have a material ID of 1, for example. So I'm going to show the workflow. These are the selection masks that we use, and those, when you bring those into Nuke, for example, what you can do is you can apply characterizations just on some objects, or just on all the objects that have a certain material, something like that. So let me show you how this works. For example, if you take a look at this object here, this is the material. I have gone and created. Okay, I'm going to click V-Ray material ID. And this will bring a new extra attribute which allows me to specify a multimatte ID. So I'm going to say, let's say, 10. So right now, all the objects that have this material are named 10. So what I can do is I can go to multimatte, create a new render element here. This one. And I can specify that I want the red object to have an ID of 10, for example. So this is going to create a mask for me that has just this particular object inside. So let me show you a bunch of compositions that were made here in this way. And the cool thing is that I can, of course, save this image into an OpenEXR, and I'll have all the render elements inside one file, so I don't need to, again, load 20 different nodes inside of Nuke. So here's the composition in Nuke. What's going on here? We have this read node, which is basically reading the original. This is the original image. And we use several shuffle nodes to bring out the different parts of the image. So we have the diffuse, we have the light. This is just the GI, the reflections. This is the fog, speculators, and so on, self-illuminated. And we can later combine those. And on the path, while we're combining them, we can just add different Nuke nodes, which apply some color correction just to specific parts of my scene, right? So I can, for example, I'm using this mask to apply some color corrections just to the areas here which are in the red. So if you take a look at this here, you see they look like this now, and this is without the color correction, and this is with the color correction. And because I'm using the selection mask, I can apply just to the parts that I care about. So this is very powerful, and it allows me to basically go from here to here in several nodes. And I can add noise. I can extract, for example, UV spacing ratio render element, which allow me to do relighting of the whole scene and change the position of the light, change textures. Nuke is very powerful in that, doing that for us. And another thing that you can do with V-Ray is you can save this image, and right now it's not available through the interface, but when we release the script it's going to be, is with this script, you can actually save deep image data. The deep image is pretty cool because it allows me to know the depth of each pixel inside of the image. And again, you can use this in Nuke, and here's the composition of that, where you can just this allows you to again apply different color corrections on different parts of the image and completely change the way the image looks. You can change colors and so on and so forth. So this is of course in Nuke, but you can. It's important that this deep image data is supported. Okay, so this is. Now I want to show you one more complication actually about deep image. Or not. Alright, so let's move directly into Nuke and hope it's not going to crash anymore. So I don't know if you noticed, but down here we have a new button here in Nuke, and it looks like the V-Ray logo. And right now what we've been working on is we've been developing V-Ray for Nuke. So I'm going to show you an very early alpha of V-Ray for Nuke. So some crashes are to be expected because it's still under heavy development. But we were able to run it, and I want to show you how it works. So if you click on this button here, you're going to see that we have a bunch of different V-Ray nodes. And we have the render nodes here, we have some materials and some light. And you can either create the nodes from the button or just use the regular Nuke. I'm not sure if some of you are using Nuke. I see one guy that is. Okay, so the way you do this is you just type in V-Ray, and it's going to show you all the V-Ray nodes. So if you want materials, you're going to say MTL. If you want lights, you're going to write light, and so on. So the first thing you need here to render inside of Nuke is to create the V-Ray render node, which allows me basically to set up all the renders. And if we take a look at the settings, you'll see that we have the simplified version of the settings in mind. Of course, we're going to get this up to speed and have much more control, but for the time being it looks like that. And the V-Ray render basically requires that you have that you bring in some additional things. It requires a background, so I'm going to give it one V-Ray background and connect it to the renderer. And the background requires that you give it a texture, so I'm just going to give it one constant. Okay, next we want to have a scene, so I'm going to create one standard Nuke scene and connect it to the renderer, and we need a camera. Now for the moment we don't have a physical camera, but this is going to change, so we're going to use a standard Nuke camera. And let's bring in some additional things. We need a light, so I'm going to say V-Ray light, and I'm going to use the dome light. And the dome light I already spoke about is this light which basically creates a sphere around my scene and shoots direct light from this sphere into the scene. So I'm going to make it a full sphere, and I'm going to specify that I want to use a texture that I'm going to bring in with a real node. And once I connect it to the dome, you're going to see that we have this texture inside. Now the last thing we need is something to actually render. It's a piece of geometry, so I'm going to read geo, which allows me to bring in an object file, and I'm going to get this one. So the reason we're not seeing it is because we're not looking at it. So let me go into 3D space and select my camera. This is a little bit painful now. I'm not very good with the navigation side of it, but let's render from this point of view and hit up. And you can see that what happens is we get this black piece of metal of object because we didn't bring any material here. So the geometry requires that you assign some material to it. I'm going to say V-Ray, MTL, and this is the standard material. You can texture all the same settings that you can texture in Maya, for example. You can texture here, you can texture the diffuse, the opacity, the reflection, the refraction, and so on. So you can create real geometry. So let's play with the reflection color, and we can get reflected. Now this is the basic workflow that we're envisioning inside of Nuke. It's the same, basically, the same workflow, the same node-based workflow that you have here. And I want to show you a couple of scenes right now of V-Ray working inside of Nuke. Alright, so in this particular example, we have this record player, this vintage record player, and we have brought it piece by piece with all those RigGeo nodes, and to each of them we have assigned, for example, a certain type of material. And the cool thing is that, of course, you can apply textures, and you can use all the Nuke grade nodes before the texture is actually connected to the material. So this allows me to very quickly set up things here. And you can see all these materials we're using textures. Here is the interesting part in this scene that I'm showing, is that the V-Ray blend material works a little bit differently inside of Nuke. Basically, we have the blend material, and it requires that you bring one material directly and one material through a V-Ray blend material input. So that's the way it works. So this is my base material, this is my top material, and when it goes through this blend material input, it reads this texture and understands that the black parts are going to be the base material and the white parts are going to be the top material. And other than that, we don't have anything special, so I'm going to enable this node and zoom in on the rendering. So having V-Ray in Nuke can be very useful, because you can, with the standard scanline render, you're not able to do all those ray traced effects like ray traced motion or ray traced depth of field. You cannot do ray traced reflections like that. So this can be very useful. And you can see these are some very complex material. I mean, there's a lot of blurry reflections and that are difficult to render, but we still get this nice productivity V-Ray. And it may look like this is a scan line, but it's actually not. It's just the buckets of V-Ray going from side to side. We're not able to render in a scan line mode. Now the cool thing is that once you finish and you get the output from your render, you can pass it through Nuke standard nodes and apply color corrections inside. So basically we're trying to bridge the gap between the 3D people and the guys in compositing, because there's a lot of back and forth, give me this pass, give me that pass, I need this, I need that. So this way you'll be able to do things much more quickly. And this I have a very simple example. What we're doing here is that we're showing off this PTX node. So I have this van. And we have given it these materials, but the textures on these materials are actually PTX textures. So they were painted, in this case it was in Mudbox, but you can also paint them in Mary. So get directly from Mary, you can bring it into Nuke with the help of V-Ray in this PTX node. So you can get, without having to do any UV unwrapping, you can render out those textures inside the V-Ray here. Now this is a complex example. I need to show something first. So here's a few screenshots of this object that we have. It's around 15 million polygons, and what we want to do is render this inside. Now, because Nuke is not exactly a program for 3D, it's not like my special example. You may get some troubles bringing this into the 3D environment of Nuke. If you just save it as an OBJ file and put it into Nuke, you probably won't be able to even rotate the camera, let alone render it. So this would require a lot of memory and really nice graphics card. So instead of using the standard read geo node, you can use this node called V-Ray proxy. So what we did is this object, it was created in Maya, and we saved it as a V-Ray proxy file from there. Or you can create it in ZBrush, for example, save it as an OBJ and convert it to a proxy file, to a V-Ray mesh file. And we are using the V-Ray proxy node to hold this mesh. And this allows us to basically, let me see if I will be able to see this mesh. Here's the mesh. Now we see it as a just a box, a bounding box, and if I want to, I can display it and show the actual parts of the proxy that we're rendering. But this basically allows me to render millions and millions of polygons inside of Nuke. And the way we're able to do this is by using this functionality called dynamic geometry. We have the same in Max and in Maya. I'm not sure if you're familiar with that. It basically allows us to store all this geometry on the hard drive, and during rendering, V-Ray only loads small parts of the geometry. Only the parts that are currently being rendered are put into the memory. We render them, we kick them out, and we have all the memory needed. So I can render this even on 32-bit machines. Actually, the V-Ray proxy was created when we only had 32-bit machines and we wanted to render millions and millions of polys. The proxy was the only way. Now you can buy 64 gigs of memory, you can still render it. But if you don't want to do this, the proxy is the best approach. You can do this in Maya as well. And let me see if I can just show the render output. Alright, Nuke is not cooperating very much today. Okay, in this scene, let me just render it out. We have this plane, and we're actually animating it. So this propeller here is actually rotating in the animation. I can show you. And if we want to be able to get the motion blur of this rotation, it will be very difficult to just a scanline user. You really need to do some real ray tracing to be able to get a nice motion blur. So you can do this with V-Ray, and I'm just going to go to the settings here and enable the motion blur. And you'll be able to see that we get one common problem here, that instead of having a nice arc where the blade is rotating, we get a straight line. And the reason is very simple, is we're just not using enough geometry samples. And V-Ray can very easily fix that. If I just go here and enable the increase the geometry samples and use like 10 geometry samples, I'm going to fix that. But I'm also going to sample all the other geometry that actually don't need to sample. So inside of Nuke, we have this node called V-Ray object properties, which allows me to basically specify on a per object level. I'm going to put this in between the renderer and the geometry. I can override the motion blur samples, and I can say for only this object use 10 samples, for everything else just use the regular 2. So again, I'm going to produce nice motion blur, real ray trace motion blur. I'm not going to use the velocity render element, for example, but I'm going to do this in a more efficient way. And this is the same object properties node allows me to do this object IDs that I showed you with the multi-matte render element within the Maya part. So I can also use this to extract some masks. And let me show you an example of that. Okay. In this example, what we have is that we have this cat model of a car that we're bringing inside of Nuke, and we're lighting up and rendering. And you can see that we have a really high poly count here. And this is obviously cat data, so what I'm trying to show is that we're able to render this very easily. Now I'm using some settings for that are decreasing the quality so I can render things more quickly. That's why I get this noisy image. And I just want to show the workflow that we've done here. So these are all the nodes here. They're loading the geometry, applying the materials. And a new node that we're using here that I haven't shown you yet is the V-Ray render element node. So if I bring it out, you'll see that it basically allows me to split off different parts of the image as render elements. I can split off the lighting, the diffuse, the same thing like in mine, and I can also do this masking. So for example, here's the self-illuminated, here's the refraction, and this is a multi-matte render element that is enabled, but I didn't fix anything to the red object. So I'll specify an IDF1, and I have applied to my geometry this very object properties node that I showed you earlier. Here. And then you see that after the rendering is complete, we're using again the same shuffle nodes to split off the different parts, and I can now take this before I combine the diffuse with the rest of the image. I can change a little bit here, and this is going to change the image immediately. So this is now the scan line going over this image and changing without me having to pre-render anything. I'm able to control it. So let's play a little bit with the reflection as well. And you can see I'm able to kind of create those this look of a chameleonic paint, which is changing color based on the angle at which we're looking at. And let's switch this node. So I basically created a switch node to increase the quality with one parameter, so I'm going to render this out at high resolution now. So that's pretty much what I have to show. If you have any questions now, I'll be happy to answer those. V3, sometime next year. I hope before SIGGRAPH so that I have something useful to show. I don't know exactly. But it's on the way. I mean, I know it's the development cycle has begun, and the guys are working, but we cannot really specify a specific date because we want to get it right, not just for something.
After Effects at all, like
it's not in the roadmap at the moment. Yeah.
a feature RT for me.
This I'm not sure about this. The thing is that you can see that we're not even able to render the buckets the way we want them. We have to use this scan line thing. It's because of the architecture of things, so I'm not sure that the art is feasible. Yep.
Do you plan to do an expo between Maya, Max, and Nuke?
Between Maya, Max, and Nuke? Between Maya and Max, I think even in the next service pack we're going to support Alembic, so I can remove geometry material sites. I'm not sure you can use that in Nuke. In Nuke you can also view a scene file, so that's one way. You can also use proxies. Yes.
Jimmy, for the Maya RT, is the additive node supported in the blend node? You know, when you have car paint and you want to put a clear coat on top, and you have additive. That's all supported.
Yes, all the options of the blended materials are supported. The only materials that we don't support is the subsurface material because it requires a prepress. And we don't support dirt text map because it also requires a prepress.
What all features of V-Ray be inside Nuke? As in distributed rendering, CPU rendering, GPU rendering?
Well, GPU only works with the RT, so if we get the RT to work inside of the Nuke architecture, obviously it's going to work on the GPUs as well. I'm not sure about distributed rendering because well, I'm not sure how it can be implemented inside of Nuke, so we'll have to see. It's a very, very early stage, right? We've been looking for a couple of months on that one, so that's what we can show you right now. Yeah.
Can we imagine in Nuke like importing a geometry and re-exporting, for example, a normal pass, a neo pass, or something like that?
Yeah, you'll be able to do that.
Okay.
All right. But if you don't have any more questions, that's all.
Thank you.